All right. Welcome back, everybody, for another deep dive.
Yeah.
This time we're looking at, kind of how AI thinks, or at least how we can get it to think a little bit more like we do. And we've got like the usual stuff, right? We've got some research papers and summaries, and I think there's even some study guides in here for this one.
Oh, wow.
Which is great.
Yeah.
So it's all about this new model called LLaVA-CoT. If you had a chance to look at this one yet.
Yeah. I had a quick look through the papers, and I think it's really fascinating because it seems like it's really addressing this key problem in AI, which is like, AI models are good at doing very simple tasks like describing an image or, finding objects in an image.
Sure.
But when it comes to complex reasoning,
right,
they kind of fall apart.
So it's like they're not showing their work.
Exactly.
You're just giving an answer.
They're not thinking step by step. So, they're not really reasoning through the problem. And LLaVA-CoT is really trying to approach things more like we do as humans by, really breaking down the reasoning process into clear stages.
Interesting.
And what's really cool is that it's actually a lot smaller than some of the existing models.
Oh, wow.
But it's outperforming them in these reasoning tasks.
So it's like smaller and smarter.
Yeah, exactly. Yeah. It's kind of counterintuitive, right?
Yeah, that's really cool. Okay, so how does that even work?
Well, the way it works is that instead of just jumping straight to an answer, it breaks down its reasoning into 4 distinct stages: summary, caption, reasoning, and conclusion.
That makes sense.
Kind of like chapters in a book.
Oh, I like that.
So it's sort of setting the scene and then diving into the details of what it sees in the image.
Right.
And then thinking through the problem and coming to a conclusion.
And then bam, conclusion.
Exactly.
Yeah. And I noticed, I was looking at some of the examples, I see these tags like summary, caption, reasoning, conclusion.
Right.
It's like we're seeing what's going on inside its head.
Yeah, and those tags are actually really crucial because they guide the model's reasoning.
Okay.
And they found that if you remove the tags, it actually hurts the performance.
Really?
Yeah, it's like the model loses its train of thought.
Wow, interesting. So one of the things that really stood out to me is this LLaVA-CoT 100K data set.
Yeah.
Like how they actually trained this model. It's not just some random collection of images and questions, right?
No, it's very specific. And they actually use another AI called GPT-4o to create detailed reasoning examples for each question.
Oh, wow.
So it's like having a super tutor providing like step-by-step solutions.
Nice.
And they actually incorporated like a whole variety of different visual question answering data sets. So it's been trained on this really broad range of information.
Interesting. Okay, so can you walk me through like how this model actually arrives at an answer?
Sure.
I read about this stage level beam search, but it sounds super technical.
Right. So imagine a detective following different leads in a case. So at each stage, summary, caption, reasoning, conclusion.
Right.
The model is actually generating multiple possible responses, and then it's choosing the best one to move forward with, based on what it thinks is the most likely path to the correct answer.
Got it. So it's not just spitting out like the first thing that comes to mind.
No, it's evaluating and constantly refining its thinking.
That's really cool. And how's this approach actually performing?
Well, the results are really impressive.
Okay.
LLaVA-CoT consistently outperforms its base model, which is called Llama 3.211b Vision Instruct.
Okay.
And it's also beating larger, more complex models on some benchmarks like MMStar, MMBench, and MathVista.
And those are specifically designed to test reasoning, right?
Exactly. They test logical reasoning and problem solving.
Gotcha. So it's not about size, it's more about strategy.
Exactly.
Like LLaVA-CoT is showing us that, a well-structured approach can beat brute force.
And what I find most interesting is that it's doing this with only 11 billion parameters, which is actually relatively small for these kinds of models. Really? So it really challenges the assumption that you need these massive models to achieve groundbreaking results.
It's almost like they found a more efficient way to think.
Exactly.
Which could have huge implications for making AI more accessible.
Yeah. Absolutely.
Maybe even getting it running on our phones.
That's the hope. That's what researchers are really working towards.
That's exciting.
Trying to make these powerful AI capabilities available on everyday devices.
That's awesome. So we've talked about how it works and how well it's doing. But before we jump into all the cool stuff that it could do, I kind of want to go back a little bit.
Okay.
And delve a little deeper into this whole structured reasoning approach.
Sure.
Like, why is this such a big deal? And how is this different from how other AI models think?
Right. Yeah. Well, A lot of the traditional vision language models kind of rely on what we call these black box approaches, where, they're learning these complex patterns from huge data sets. But it's really hard to understand how they're arriving at their answers.
Right.
Whereas LLaVA-CoT, with this structured reasoning,
Right.
it's very transparent.
Okay.
We can actually see each step of the thought process,
Gotcha.
which makes it a lot easier to understand, evaluate, and actually trust the conclusions.
So it's kind of like the difference between just telling someone the answer and showing your work.
Exactly.
Like you get a much deeper understanding of how you got there.
Exactly. And that's really important when you're thinking about applying these models to real-world problems.
Right.
Imagine an AI doctor that's diagnosing a patient.
Sure.
You don't just want to know the diagnosis, you want to know the reasoning behind it.
Right. Right. Now, I'm curious about, we've been talking about vision and language, but could this structured reasoning approach be used in other areas of AI?
Oh, absolutely.
Yeah.
Like what?
The core principles of LLaVA-CoT, like breaking down complex tasks into smaller steps.
Yeah.
Right.
Providing clear guidance and using these intelligent search methods, those are things that can be applied to a lot of different fields of AI.
Like what specifically?
Like natural language processing, robotics.
Oh, wow.
Even decision-making systems.
So it's almost like we found some fundamental principle of intelligence, whether it's artificial or human.
Yeah.
This idea of structured thinking.
Yeah, the ability to break down problems and reason through them step by step is really fundamental to intelligence.
That's really cool. So I know that the team behind LLaVA-CoT, they've hinted at some exciting future directions.
Oh, yeah.
Like what's next for this whole structured reasoning thing?
Well, one of the things they're looking at is actually using external verifiers
Okay.
to kind of double check the model's logic.
So it's like having another AI check its work.
Exactly. It's like having a peer review for AI reasoning.
That's pretty cool.
Yeah, to make sure that the conclusions are valid.
So it's not just AI thinking. It's
Right.
AI thinking critically about its own thinking. Wow. Okay. And what else are they looking at?
They're also looking at incorporating reinforcement learning techniques,
Okay.
which would allow the model to actually learn from its mistakes
Cool.
and continuously improve its reasoning abilities over time.
So it's like, it's not just teaching AI to think, it's teaching AI to learn how to think better.
Exactly.
Wow. That's really cool.
Yeah.
And so this research could have like big implications for how we design and build intelligent systems in the future.
Yeah, I think it has the potential to really change the way we think about AI development.
That's fascinating. Okay, so we've covered a lot today. We've talked about how LLaVA-CoT works, its structured reasoning approach, all the amazing stuff it can do. But I want to bring it back to our listener.
Okay.
Like, why should they care about this vision language model that can think step by step?
Right.
What does this mean for their lives?
Yeah. I think the key takeaway is that this isn't just like some research project in a lab somewhere.
Okay.
This is really a fundamental shift in how we're approaching AI as a whole.
Right.
It's about creating systems that can reason transparently,
Yeah.
explain their logic,
Mm-hmm.
and ultimately help us solve these complex problems in ways that we couldn't before.
So it's not just about building a smarter AI. It's about building an AI that we can actually understand
Exactly. Yeah, it's about building trust.
and trust so that it can actually be a partner in problem solving.
Exactly. And the potential applications are huge. I mean, imagine AI assistants that can help you with everyday tasks.
Right.
Like writing emails or even understanding like really complicated scientific papers.
Yeah. Or like helping doctors diagnose patients.
Yeah, exactly. And providing evidence to back up those recommendations.
So we're talking about AI that could revolutionize medicine, education, engineering.
Any field where reasoning is essential.
Yeah, what about scientific discovery?
Oh, absolutely. Imagine AI systems that can analyze these massive data sets,
Right.
identify patterns, and come up with hypotheses that would take human researchers forever to figure out.
Yeah, it's like giving scientists a superpower.
Exactly. It could really accelerate the pace of discovery.
That's awesome. And, like we were talking about earlier, this technology is becoming more accessible.
Yeah.
So
Yeah.
with the efficiency of LLaVA-CoT, like maybe we could actually get these models running on our phones.
Yeah, I think that's definitely a possibility.
That would be amazing.
It would be like having this incredibly intelligent research partner in your pocket.
Oh, wow. But, with all this amazing potential, there's also responsibility, right?
Absolutely.
Like we need to make sure that we're using this technology ethically.
Right. Ethical considerations have to be front and center as we continue to develop these systems.
So we've got to think about bias, fairness, transparency, and accountability.
All of those things are crucial.
And making sure that this AI is actually used for good.
Exactly. We need to guide the development of this technology so it benefits humanity.
Right, it's a balancing act.
It is, but I think the research we've discussed today, with LLaVA-CoT and this focus on structured reasoning, it gives me hope that we're actually moving in the right direction.
Yeah.
We're not just building AI that's smarter.
Right.
We're building AI that's more understandable, more transparent, and ultimately more beneficial for everyone.
Yeah, that's a great point. So this has been a really fascinating deep dive into this whole world of structured reasoning in AI.
It has.
And for all our listeners out there, I highly encourage you to check out the source material.
Yeah, especially those study guides.
They're really great.
They go into a lot more detail.
Yeah, so dive in and explore this stuff because it's really incredible.
And this is just the beginning.
Yeah.
AI is constantly evolving, so who knows what amazing breakthroughs are just around the corner.
That's the best part.
It is. It's exciting.
Like that constant exploration, the pursuit of knowledge, all these possibilities.
Yeah.
Well, thanks for joining us on this deep dive, everyone.
Yeah, thanks for listening.
And keep asking questions, keep exploring, and keep diving deep. Until next time.